Swayam Prabha. Digital India. Educated India.
Okay, so what we have done in the previous lecture is steady flow. Everything we dealt with the steady flow, but we moved from Stokes drag for a uniform flow to more complicated, to really complicated with Faxon's theorem. Okay, but they are all good for steady flow. What happens if the flow is unsteady? Okay. That's what we want to look at in this lecture, and that problem has been solved by three guys: BBO, Bassett, Boussinex, and Oseen. Okay, many of you are familiar with that. Okay, so they wrote the equation, and I just want to not derive the equation, but I will talk about what the results mean. So now these guys did not. They are now looking at the problem just the opposite of what Faxon did. Faxon said, give me any complicated spatially varying flow but make it steady. But Bassett, Boussinex, Oseen said that, oh look, I just have a uniform flow, but it could be varying in time. Maybe I may oscillate the flow, I may ramp up the flow, but it's always uniform. Now the next step in the next lecture, what I'm going to do is that put both of them together, Faxon and BBO together. Then you have spatially varying flow, now time dependent, so that we are now going towards most complicated flow, but all of them at 0 Reynolds number. This is just like a building up our capability. So what does BBO do? They do unsteady problem, but it is for an incompressible flow, it's for the Stokes limit, and it's a spatially uniform. This is the limitation, and in that case they derived the equation. Okay, and I'm not going to worry about all this derivation that I covered in the when I gave this course in greater detail. But the idea is they solve the perturbation problem. Now remember, when the answer comes, I said that we get the drag and it's written in terms of the undisturbed flow. How do we get that answer? How did Faxon get that answer? He tries to solve, so he does the difficult part. So BBO did the difficult part, which is they solved the Stokes flow, unsteady Stokes flow around a particle for temporarily varying ambient flow. So these are all the derivation steps. Okay, and I don't want to burden you with that. Okay, because I'm pretty sure all of you are ready to look at that, so you can solve this, and you finally, when you get that perturbation flow and you integrate the force or the stress on the particle, you get the force. This is the equation that you get. This equation that you see here. What is this? This is nothing but, you can think like a black box. Give me a time dependent undisturbed flow. This inside this black box, it takes care of all the perturbation flow, etc., and he says here is the force on the particle. So all you have to supply here is UC. So by the way, there should be a C here. That's my mistake. So this undisturbed flow, this is what we got previously. This is the only thing that Stokes drag would have given you, and this is called quasi-steady force because now you see the uniform flow is a function of time. It could be an oscillatory flow. So at every instant you say, what's my relative velocity, and say, okay, that's the force. Stokes drag for that relative velocity. Next instant, maybe the relative velocity is higher, more drag. But then when you vary the flow in time, when there is acceleration, there are three other guys show up, which makes the problem very hard. So in other words, in an unsteady problem, you have not just the quasi-steady force, but you also have other complications. Now I said previously that you have undisturbed flow force and perturbation flow force. So in other words, the undisturbed flow, even without the perturbation due to the particle, that is this term. This is the undisturbed flow force, and these three guys are due to perturbation flow. Okay, so if you want to be oscillating the flow, you must have a pressure gradient, and that pressure gradient will pass on to the particle, and that's this first term. That's the undisturbed flow force. Okay, and when we come back, I will go through what the physical meaning of these three terms in a little bit more detail. The next thing that we will do is that put spatial variation and temporal variation, and we will try to see. So that will sort of complete this force discussion. Thank you.